Assalamualaikum and good morning. My name is Muhammad Syaki bin Muhammad Kamal. We are from Group C. My group member are Ikmal Isham bin Rosli and Muhammad Ayul bin Muhammad Fazil. Today we would like to explain about Lab 5 AM modulation. So first I will explain about my part, which is task 1 and task 2. So this is the circuit for task 1. Uh, the que The question for task 1 is simulate and visualize the output waveform and study the circuit. So this is the output and input. The red waveform is input and the blue waveform is output. So we can see that the output is not like AM signal. It is because the positive and negative peak of the carrier wave are not connected to an imaginary line. This line called envelope help to recreate the exact shape of the modulating signal. So next is task 2. So this is the circuit for task 2. So the procedure is same like task 1. So this is the output and input same like task 1. The red one is input and the blue one is output. So we can say that the output waveform is like AM signal. It is because the output waveform is like envelope shape. Envelope is formed by the carrier peak and is identical to the shape of the intelligent signal. So next for task 3.
So for the task 3, the first one, keep the same given circuit in figure 4.2 and multiplication. Next, fill up the table 1 for different values of V2, but we keep the value of V1 at 1 kilohertz. So the plot V2, Y axis versus peak V RMS X axis. Then we get the table like that. We change the value of the V2 and we constant the value of V1. So in this task, we change the voltage of V2. V2 is the message signal. The amplitude of the highest peak VRMS increased irregularly as the voltage V2 was increased. The amplitude of the lowest peak VRMS decreased irregularly as the voltage V2 was increased. This shows the Vmax increase and the Vmin decrease irregularly. So see the graph. Minta buka. Ah, this is the graph that we get for V2 y axis versus peak VRMS axis. Okay, next for the task 4.
Okay, for task 4, as we know, modulation, amplitude modulation made up of carrier wave and message signal. So, if you can, we kejap buka apa table. Yeah, okay. If we can see the V2 as the frequency increases gradually, while the amplitude for the VRMS one, if you can see there, it's increase, it's increase and it's decreases at the same time. So same goes as we can see at the amplitude for the VRMS, whereas you can see when it reach to the 1.923 started to increases back. So from here can see that V2 frequency, V2 the message signal. The amplitude of the high environments decreases as the frequency increases. The amplitude of the lowest peak VRMS increases irregularly as the V2 increases, as the V2 frequency increases. This show that decrease in Vmax and irregularly insertion of V minimum. And that's all. Thank you.
So that's all from us. Thank you.
Thank you, sir.